Syntec was started in 1980, and they were geared towards high precision plastic parts. Gears primarily was their key competency at that time. And we actually still do quite a few plastic gears for companies like Kodak, Heidelberg, Universal, Hoover Davis. You know, gears are very tough to mold in plastic as well. But that, again, that core competency of being willing to handle tight tolerances and difficult tools is what led to the natural progression into optics to Syntec. We have 13 molding machines here running various different parts, medical applications, defense applications. The molding end of things is really our core competence. It's what we do better than most injection molders in general. This here is a really interesting part. This is one of 3 parts we make for basically a telescope used in laser eye surgery. And this particular lens actually sits on the eye during the surgery. This is called the contact lens. Well, the injection molding process basically takes very small pellets of plastic. This is the raw material. So one of the first things that has to happen is the plastic has to be dried. So we put it in this hopper, which is heated and ventilated with hot air to dry the plastic. The plastic is then drawn into a barrel which has a screw which is under pressure and temperature to basically take it from a solid to a liquid state. The plastic is then injected by the screw into the injection mold. You can see these are the temperature controllers for the mold. This all comes together to make our parts. This is another one of the lenses in the laser eye surgery telescope. This is actually the objective lens, or the eyepiece lens. We try to use as much automation as possible, robotics to deliver the part to a conveyor system. This allows us to get some efficiencies with operators. Now one operator, rather than waiting for the machine to give them the part, can run multiple machines, and they just simply come over and pluck off all of the parts from the last 20 minutes or 30 minutes, whatever, from the conveyor to inspect and package and finish the parts. Third piece of the telescope for the laser eye surgery. This is the wide field lens. But with working with our customer, we actually help to redesign the product to reduce the number of components in it, the overall cycle time. We reduced the cost and improved our ability to make the volumes. Their sales have been just going through the roof. So it's interesting, those actually get out. We ship them to a company who packages them up and uses gamma radiation for sterilization, and then packages them for use in the surgical field where they're individually packaged. The surgeon's basically going to open up the package, take out the 3 lenses, build the telescope, and then at the end of the surgery, throw them all away. This was a really cool project we worked on, and they're used in a camera, which is, you might have seen the commercials recently, it's attached to the cell phone. Right, and it's a projector, and you can project a video onto a screen or the wall or wherever. Each part has 3 optical surfaces, and by the way, prisms are probably the most difficult shape for a precision plastic optic because of, again, the varying cross-sectional thicknesses. Ideally, you would want uniform thicknesses, which you can't have with a prism. This is the quality department, where we inspect our products. We have several pieces of equipment used primarily for inspecting optical components. This is a polarimeter that I built, and what it is basically it's 2 pieces of polarized sheet that I have crossed. It helps show the patterns, the flow patterns of the plastic, where the parts are stressed and where they're not stressed. In some of our customers, this is very critical, especially if they're going through a lot of thermal variations in their product line.